So now let's take a look at this problem here. This says find the Taylor polynomials for P0, P1, P2, P3, and P4. Oops, I forgot to put the x equals 0 here. And then I have a period. So anyways, this is where we're centered at. So again, I'm just going to follow the formula. So there it is. So my P naught or P0 would just be my f of 0. So sine of x, so sine of 0 would equal 0. So P naught is just 0. That's my first polynomial. So then my P1 is just going to be f of 0 plus f prime of 0 x. Now generally I have the x minus a, but since our a is 0, we don't have to have the minus there. So that would be our P1. And when I simplify this, this would just be x. Now keep in mind here, we would have to find all of the derivatives for these for up to P4. But again, I still have those on the previous page here. So I'm really just going through 4 here. So I'm just going to go through here. So those are the ones I'm going to need for the next page. So here they are. So now what we're going to do is we're just going to do the rest of these now. So then P2, then is going to be f0 plus f prime of 0 x plus, and then now I'm going to be doing a third one, so f, or the second one, excuse me. So f double prime of 0 over 2 factorial x squared. And when I simplify that one, I'm going to have to go down to the next row here. F of 0 is 0. F of 1, that's going to be 1x. And then F2 is also going to be 0, so I just get x. So my P1 and P2 are the same. So now I'm going to do P3. And P3 is just going to follow that same pattern. So f of 0 plus f prime of 0 x plus f double prime of 0 2 factorial x plus x squared, plus f triple prime of 0 over 3 factorial x cubed, and that's where I stop at. So then when I simplify this, this gives me 1x plus, remember this is 0, that's 0, and then that's going to end up being, minus 1 over 3 factorial x cubed. So there's my P3. And my P4, since my next one is going to be 0, my P4 is just going to equal the same thing as my P3. All right, so there's P1 through P4 centered at 0. So now going up to P4 this way, we notice that P1 and P2 are the same, P3 and P4 are the same, P5 changes, P7 changes, and I just kind of want to show you how all of this looks graphically now, and the whole reason for doing these Taylor polynomials all together. So let's just take a look at this. This is interesting. So really we just have our P1, P3, which is down here, and then P5 would be those 3. That would be a P5. And then P7 would be those 4. So what we're going to do now is I just kind of want to show you how this looks graphically. Okay, and keep this in mind too. 5 factorial starts to get big there. 5 factorial is going to be 120, and 7 factorial is 5040. So those are the numbers we're going to start to see here when I show you this graph. It's pretty cool. Take a look. Now this is the first graph. This would actually be our P1 here. And if we graph it, notice we're centered at 0 here. So this honestly is just our line, our tangent line. This is our linear approximation. And if you look at the formula for that, notice what it is. I take the derivative, and the derivative here is going to be our slope. And this here is our y-intercept, and that would be our x. So that's where that comes from. This whole idea that we're dealing with here is dealing with the idea of linear approximations, quadratic, and so on and so forth. So now this is the first one here. And remember, we're centered at 0 here, so we're going to be exact on intervals around the 0. And that's what's really cool. So just keep an eye on that as we continue. So here's our next one, and it just goes a little further than the blue line there. Now my exact gets a little bit further out. So now this one even further, the darker colored one, now I'm way out here. So now this one even further out. So that's what we start to see with these, that as we get further and further out with these Taylor polynomials, it gets more and more accurate further and further out. So you see this one goes out to here. And then the black one before that goes to about here. And it even shows the little dots on there, which I really like. And then the green one there, that's going to be, or was that the green one? That was the green one. Okay, the black one is probably about here. You can see it on the line here. And then the blue one then is just at the point in the center, because after that it's off the curve. So anyways, you kind of see how this comes into play. Now I could go out as far as I need to be as accurate as I need to, or I can go all the way to infinity, and guess what's going to happen? It's going to wrap all the way down. I just want to show you one more. So now looking at this one, this is a P11, and it goes almost out to 5 here. So they start to get up there as I go out. So that's what's really cool about this. Now if I just took the whole power series and graph that, it would completely continue to wrap all the way from negative infinity to positive infinity. And to think about it this way, this is how we can actually look at our interval of convergence as well. Where is my function going to equal my power series at on its interval of convergence? So that's kind of where all that stuff kind of comes together a little bit more too. And we're going to do a lot more with it in this section.